All right, let's go over the next lab, Lab 8, real quick. These Lab 7 and 8 should not be that difficult. They probably are going to be one of the easiest ones because they're really just taking the code you've already written, updating it, and moving it over and basically trying to make it compile under a new, I guess, framework. So we talked about templates today. We're going to go ahead and take our int array class and convert it to an array class, template it on type. That way the array class doesn't have to necessarily be of ints. It could be of ints, doubles, floats, strings, or any other class that we decide that we want to define. In fact, what else could we do? Could we have an array templated on an array, templated on integers?
Sure.
And what would that be?
So I have no idea if I use the heck
Array templated on an array?
Mm-hmm.
Templated on another array?
No, an array templated on array, templated on integers.
Isn't that just like numbers?
Kind of. But what is it? It's really just a, well, one array templated on integers is a 1D array, so an array templated on array templated on integers is a 2. There you go. That's all. Yeah.
Well, when it came out of your mouth, it sounded very complex.
It sounded very complex. Yeah, it did. It did sound complex. But I want you to understand that you can template on anything.
Anything?
Yep.
Oh,
You can.
yes. And
You can template it. Remember, you can template on pointers as well. And what can pointers point to?
anything.
All right, good. So, back to arrays. So, array, notice we've templated on type T. These functions should look very familiar. The first one does a deep copy, give you an array, a standard C array, and a size. Copy it over. Hopefully that's a lot of copying and pasting of code. Next one, you copy another array, type T, with a list. Notice here I'm passing in another class of array templated on T. Get length. Hopefully that is straightforward. Notice I put the word const, just to make sure you have const at the end of that function. All it means is that function is not going to change any of the member variables inside of the class. Hopefully get length doesn't do that. If it does, please talk to me. I'm kind of curious why it is, but you know, whatever. Index of, same as last time. Remove, same thing. Here's an operator overload. Retrieves the element at a position opposed. So returning a T reference, so you need to actually return that variable itself. This is replacing .get. An operator double equal as well. This replaces .equals. And then make sure you free the memory. All right. Again, since arrays template, we include the CPP template class is not implemented until utilized or explicitly declared. Test cases due 1 week. Make sure there's no memory leaks. Any questions? No questions? All right.
Not yet.
Not here. All right. Well, let me go ahead and stop here. I think we did a good job of starting to catch up. Please go ahead and get.
Labs are doing Monday, and our project's due Wednesday.
That sounds right.
So, 3 labs in a project
Are there 3 labs in the project?
next week.
Oh, beautiful. All right. I'm sorry, Alex.
I'm gonna throw up.
Look, just knock these out over the weekend. These two, hopefully, they're mainly getting it to compile. You already had your code from Lab 4 and Lab 6.
Yeah, hopefully it's right.
Hopefully it's right.
Yeah.
I mean, I did run some test cases, but yeah.
Wow. All right, I'm going to stop now and help people make sure the autograder is working. The autograder did go through a couple of changes, so there is a possibility that it is the autograder that is messed up right now. So we just need to make sure that's correct. Any other questions? Good. All right.